So this is the joint workshop between 12 Labs and Pinecone. Here's a quick agenda that we have, which is I think for the first part, we'll from my side, we'll quickly talk about 12 Labs, our company product and the technology that we build, and then for the second segment of the workshop, I'll pass it to Barry to quickly walk over vector database and vector search capabilities from Pinecone, and then we'll have like a quick 7 to 10 minutes walk over a tutorial / Google Colab notebook that we built on how to use 12 Labs and Pinecone to chart with videos, and finally a couple of slides prepared potential ideas that you can build using our technologies for the corresponding categories in this workshop, in this hackathon. So a quick slide about 12 Labs, the company we founded about 4 years ago. I'm personally based in San Francisco. We also have an office in Seoul. We focus a lot on building proprietary models, as well as a platform on top of our models, working with different major enterprise customers, backed by top tier VCs, different partners, and I guess that top of mind is definitely security, privacy, etc., to make sure that we meet requirements from enterprise customers, right? So the focus of 12 Labs is on video understanding, and the reason is that we believe by the end of this year, video will probably make up to 85-90% of the world's data, given the massive amount of streaming content, television, filming, etc. In the digital world, right? And so I think another important point is that as humans, right? Video is our first language. We perceive the world, we interact with the world in actions, visually, not just based on words or sound, right? So I think from the 12 Labs company mission and technology point of view, we believe that by solving video understanding, I think we can solve human level understanding with machines, right? A couple of things about existing limitation of traditional solution for video understanding. So in the past, most solution has been relying on computer vision models to do manual tagging, generating metadata from videos, right? So things like recognition, Azure AI, Google Vision AI, right? And the issue here is this metadata or the tags, right? They cannot capture full meaning of the video, and they do not provide enough context, right? And as a result of that, you can only see very limited information provided by those metadata or tags, right? So you cannot do a complicated search query, for example, receiver catch a depot for touchdown. That's a pretty complex query that requires understanding of different objects, but also activities, which I think for traditional CV model, they just cannot capture that. There's another approach of solving video understanding, which is using actually large language model to process image level within the video. So for example, they try to break down the video into set of frames, right? Maybe they sample 5 to 10 frames out of the whole video, and then they try to do some sort of image processing on those frames. But the issue here is processing frames across a large amount of video is exponentially expensive, right? If it's a long, a 1 hour, 2 hour long video, then there's very high amount of information that you need to process if you break that video into frames, right? And that will come into the issue with cost as well, right? So all the LLM model in the market, right, whether it's Claude or OpenAI, right, by treating video like image or text, you first of all poor understanding, because you cannot capture the temporal aspect of the video, but also in terms of cost, right? Like I put here in the slide a couple of high-level napkin math, right? If it's like 1,000 hours of video, then that will have about 3.6 million frames, right? Which if you multiply that by the cost of like a small API code, then that can easily up to $5,000, $6,000, $7,000 per API code, right? So with 12 Labs, we think from first principle, and we try to build video native foundation models from the get-go. That means our model can, did a pretty good job of spatial temporal understanding within a video. So capture both, the motion within the video, but also like space and time, like that intersection. I think that's what makes video pretty unique. In short, we built two models. The first one is called Marengo, which is a video embedding model that take in video as input, and it generate vector embeddings from the video. So these are multimodal embeddings that capture all the information in the video itself, whether it's appearance or motions or speech or OCR, right? Each of these modality, each of these concepts within the video will get their own specialized vectors, and when you got these vectors, right, you can perform a lot of interesting downstream tasks. Obviously, semantic video search is a clear one, because now you can get like more fine-grained retrieval query. We also have the embed API, where we expose the raw embeddings to the end users, and you can store those embeddings in your choice of vector database, such as Pinecone, and you can perform interesting like downstream tasks with that, whether it's say data curation, anomaly detection, more complex retrieval augmented generation workflow on top of that. And then the second model that we have is called Pegasus, which is a video language model that it leverages the same encoder, which is Marengo, and then given that encoder and the user prompt, it generates text from the video. So I think like already a couple of you already try out Pegasus, right? I think so. This one projects on the Discord that doing the recipe of food, right? And you try Pegasus to generate basically like food items, ingredients in this video, right? And it generates like very clear, well-written, detailed format. The reason that Pegasus can do that is because we have this like video language alignment component, where it does a pretty good job of like align a video embedding space with the language embedding space, and then therefore can return like contextually relevant text output. So this next two slides just quickly go over like some details on the architecture of the model. So Marengo, this is the architecture, like I explained before. Each of the component of the video, whether it's motion, appearance, speech, OCR, with its own specialized vectors. I think in the AI terminology, this is called multi-vector retrieval, right? Therefore, like when you want to do very fine-grained object search, person search later on, you can like retrieve that exact clips that describe your needs, right? And then as if we did some benchmarking in Marengo against other best performing multimodal embedding models, whether it's closed source API or open source, and it does achieve state-of-the-art performance in many different benchmarks, whether it's like text to visual or image to visual or text to audio search. Yeah. And this is Pegasus, the video language model that I explained. This is the architecture again. So take into input the video and then the user prompt, and then it passes through the Marengo video encoder, go to a tokenizer that align language. That basically process the embeddings from the video encoder. And then once we got the video token and the text token, we basically have the video language align decoder to do the final processing and generate text from Pegasus. So this model 1.2 was released earlier this year, around January, and we did benchmark against like from OpenAI and Gemini, and it definitely I guess like has the best bang for the buck, which means that get the highest performance, but also like shorter latency and reasonable pricing, which is very fitting for enterprise level use cases where you probably have a lot of video and you don't want to spend too much, right? But also get like all the engineering and accuracy correct for use cases. All right, so I think that's all the slide from my first section on 12 Labs, and I'll pass it to Perry for the next few slides to explain about Pinecone.
Hey, thanks, James. Do you want to keep running the slides, or you want me to take over?
I can, yeah, just tell me when to move. Yeah.
Okay, perfect. So yeah, thank you everyone for jumping on and talk a little bit about kind of what Pinecone is. We talked a little bit the other day as well. Pinecone, as hopefully you may know, is what we call a vector database. And vectors are the machine encoding of some bit of data. So whether it's text, or in this case, or images, or in this case, video, you use a embedding model, typically a LLM based or a transformer based, and the stuff that James and 12 Labs have produced. And those models interpret whatever the data coming through is, whether that be text or images or videos, and create a vector. And you can think of a vector as a long string of numbers where each element of the array, each element of the string represents some sort of characteristic about the data. And you can think about it very simply as, how blue or how red or how orange or how white, how many legs does it have, is it an animal, is it a table? I'm being very kind of simplistic, but that's basically the model is taking each input of data and writing or determining the characteristics of it, and then storing those as floating point numbers in a long array, many thousands of dimensions long. And when you ask a question, you take your question and create the same vector, same embedding from the question, and use that to find records that are close to each other. The thing about vectors is there's mathematic computation that can describe the distance between two or more vectors. And that distance between them is equivalent to the similarity of the data points, either your question versus the underlying space. If you imagine very simply a two-dimensional graph, right, x and y, the x comma y, that's a vector. And you have some vector point that has a high x and a low y. You have another vector point that has a high y and a low x, and there's some distance between those 2 points, right? You can kind of extrapolate that to a three-dimensional space and imagine with an extra axis, an extra dimension, and then you have to extrapolate that to 1,000 or 2,000 or 3,000 dimensions. And our human brains can't really do that, but computers can, and mathematics can. They can figure out the distance between two vectors based upon all of those different dimensions. And what you end up with is a distance score. And this distance score is then representative of the similarity between those two vector points, which is then the same as the similarity between the data that created them. So 2 paragraphs or 2 images or two pieces of video. You want to go to the next slide, James? I will answer questions in a second. I saw some coming in. So, as I was saying, you can imagine this in a three-dimensional space. If on the left-hand side, the first yellow dot, we're talking about Normans in Normandy, and that question is close to the content that has already been put into the database that talks about the Normans and invading Normandy. On the other hand, on the right-hand side, you have a different set of data, a question and an answer that are not at all related to Normans and Normandy, but can exist in the same vector space. And when you ask a question, either that A in yellow or the B in yellow, the question directs you towards a set of vectors that are close. Yes, matrix math. That are close to one another. And so we use the mathematical distance between 2 points as the representation of how similar the text is. So again, if you look at this example, there's the pieces of text, and those get translated, get encoded into vectors, and they're stored in the vector space. That graph, that chart, is what we consider the vector space. You can consider that being the vector database. And when you ask a question, you're saying, I have this new vector that doesn't exist in the vector space, but I want you to tell me which points, which records are closest to that. You can ask for the closest 1, you can ask for the closest 5, 10, 1,000, however many pieces of context you need in order to drive the relevance that you're looking for. If you're looking for images to tag, if you're looking for text for RAG, whatever that is, right? So this is the kind of the concept and the mathematics behind vectors and vector space. Pinecone then allows you to store these vectors in a very, very easy to use serverless database that you can just put your vectors in and ask you questions of it. We have a very simple API. I'll walk through that in a second. Very simple API. We take on all of the infrastructure, right? There's lots of other vector database technologies out there. Most of them require you, the user, to do a whole bunch of work. You have to set up infrastructure, you have to tune the system, you have to manage the resource allocation, you have to manage the different algorithms that go into this. With Pinecone, you don't. All of that just goes away. And that's kind of a key part of what we are offering to the world. It's really everything done as a service, and you get the benefit of vector search from whatever vectors you put in and whatever query you want to take out. If you want to go to the next slide, thank you. Without getting into too much of the under the covers details, but a little bit of it, there's lots of different ways to index vectors, to create an index of vectors. Most technologies out there use something called HNSW. It's a graph-based algorithm that does a pretty good job if your data never changes. It does a pretty good job if all your data fits in RAM. But as soon as you want to keep updating data, and as soon as you have more records than can fit in RAM on a single system, you run into all sorts of problems. And so Pinecone developed our own proprietary algorithm. It's called a clustering algorithm, and it basically avoids all the problems with graph algorithms by grouping vectors into distinct clusters that we can then resize. And when you have a query, we can ignore like 99% of the clusters in your database because we know that query is close to only a small set of them. And this allows us to be very fast, both in keeping the data up to date, but also in returning queries. It also allows us to be very accurate because we're scanning just the data set that we know contains the answers for your question. And it allows us to do it at very low cost. Because it allows us to store all this data on S3, on blob storage, and charge you only for the reads and the writes and a little bit of storage that you're doing with Pinecone. It's what allows us to have a free tier. And so all of you, and we've advertised, right, for the purpose of this hackathon, can have free access to Pinecone. We have a certain quota every month that we allow. And that makes it just, again, really easy to get up and running with, really easy to use. James, you want to just go to the next slide? We'll talk a little bit about the API. Setting up Pinecone is just as simple as calling an API, right? Again, there's no instances to set up, there's no infrastructure to manage, there's nothing to choose how much of something do I need. You just, from an SDK or a REST API, say, give me an index. And you say that index should live in a particular cloud, and optionally, we can do the embedding for you. We can do the vector creation for you if you just send text, or you can set it up so that you do that creation outside of Pinecone, like you might do with 12 Labs, and you send the vectors directly to us. Go to the next slide. So writing data is as easy as just sending an upsert command. You can send batches of records, either the text for them or the raw vectors that you might have gotten from elsewhere. Go to the next slide. And then querying is the same process in reverse. You say, here's my question. It's either some text or a vector itself. and the results you get back are the handful of records that we have scored and ranked by their similarity score. So going through this quickly because we want to get to the demo. We'll have plenty of time for questions. The three main use cases that we see for Pinecone are this idea of semantic search. And this is really what today with James falls into, right? Putting a bunch of data in and asking questions of it that have some meaning behind them. It's not just looking for an exact match of a keyword, exact SQL query. It's looking for the meaning behind the data, either that text or images or videos. That then feeds directly into RAG, Retrieval Augmented Generation, which I could spend an hour talking about. And that's the semantic search is what powers those RAG applications, those RAG chatbots. And then very similarly, when we start talking about kind of machine-to-machine, agent-to-agent communication, giving each agent its own data set, its own context for performing the activities that it's going to, whether that be a chat, whether that be summarization, whether that be research or tools. And so these are the three main areas that Pinecone is being used today. And then lastly, just a little bit of an architecture diagram. If on the left-hand side you have your data source, whether that be text or images or both coming in, you assign some metadata to that, you pass it through an embedding model, and you store that data in the Pinecone database on the right-hand side. And then at question time or at search time, coming up from the bottom, that blue box, translating that question into a vector and sending that to the database, getting back a list of records, and then really deciding what to do with those records. Do you give the user a list? Do you give them a set of a JSON output, or do you give them some RAG interface chatbot on top of it? So that's Pinecone in a nutshell. And Pinecone and 12 Labs have had a partnership for quite a while now. I think the two of us work very well together. 12 Labs expertise being around understanding video and creating high-dimensional vector embeddings of that video. And those vector embeddings going to be stored in Pinecone for you to do search and retrieval over. Okay,
Awesome. Let me just pop out it real quick. Okay. So this slide, and we actually have a blog post on this, which I can put it on a chart afterwards. But we published last year, where we walked through the tutorial on how can you use our product together for like basically a video rack workflow where we can chat with videos. I was gonna spend maybe like 5 to 7 minutes walking over the notebook here, and this is written in Python SDK both products. So let's see. So the first step is the classic installation of about SDK. So here you got pip install 12 Labs and Pinecone client, a couple other like rather libraries for working with an open source model that we're going to use for this notebook, and a few like other Python specific libraries that's needed. Here we set up the credentials, right? So import the client and then grab your API key, right? So I already for this notebook we already stored the API key of 12 Labs and Pinecone like credentials within Colab, right? So we just code them, configure that. And for this notebook, we bring our own video data. So we have a Google Drive that has some pre-indexed video that we're gonna use. For example, like the video that we show here is like a advertising video, a beauty product. So I can quickly show you guys what it looks like. Let me put it here. This is the video. So okay, now yeah, it's like a beauty product of Selena Gomez. Just model talking about like beauty products, right? and we read it, and this is how you generate embeddings without 12 Labs model. So you initialize the 12 Labs client. I wrote this function here to generate embeddings. By the way, this is written last year, so it was 2.6 back then, but now I can use Marango Rich for 2.7 to generate embeddings. So this is a quick function based on our documentation on how to create an embedding task, create a sort function when the embedding task being operate. So you can see the status of the embedding task, and then you extract the embedding. So create a NumPy array, and then you append the embedding float, the start and end time of the clips of the video segment, and then embedding scope as well. And I believe this is the function to basically after generate embeddings, just store them directly in Pinecone. So yeah, this part here where you create an index within Pinecone, and within creating index, right, there's things like index name, dimension, metrics, serverless, and the dimension of our embedding model is 1024 for whether it's video, audio, or text. And that's why we define that numbers here using cosine similarities for the score. And yeah, here I just code the function generate embeddings that I define in the block above, and upsert the vectors into Pinecone, right? So I think Barry already talked about the concept of upserting. This is how it looks like in action. You just have this vector to upsert, right, as an array, and you just dot append to it. So yeah, this is I just code in just data function, and then this is an example look like that name of the video that I showed you guys earlier, right? Video products. You create a task, and then you can see the status of the embedding being processed. And after you finish, it shows that it ingests about 11 embeddings from this video into Pinecone. And the cool thing about Marango model is multi-modal, so that means it can also process text embeddings, right? So here is a simple function to do text embeddings. And so for example, like let's say for example, lipstick, right? This is a text query, and you're gonna call the text embedding function to convert this lipstick query into a text embedding, then perform like a retrieve similar content based on query embedding. So that's a very simple part about semantic video search. And then throughout the rest of the notebook, we did try something a bit more complex, which is like video formatting. The reason we did this video formatting because we want to compare our model, our 12 Labs model, with an open source model called Lava Next Video on Hyperface. So this part here is for like video formatting. We break the video down into like segments, and using that to allows that Lava Next Video to work with it. So at the end of the output, we just split 11 segments from that input video. This part here shows the power of using Pegasus to track with our video. So Pegasus is the video language model that I talked to you earlier. This is how we create an engine, create an index, and define videos within 12 Labs. So this is the part where we create an index, and then we upload that video into our index, and yeah, we just show the output of how it looks like. So basically, given that same video of Bright Beauty, we upload 11 segments from that video into our 12 Labs index. So you can see here, like for each segment here, we have like their own like status indexing, etc. And yeah, this is the part where we code Pegasus, right? We retrieve the video segment, we encode a function, and basically generate specific text about it, talking about what this video is about, right? The advertisement is promoting the beauty product, specifically for compact makeup palette, The visual focus on women applying makeup from the palette, highlighting the unique styles and convenience of the product. This is kind of what Pegasus can do, right? Quickly describe what's happening in that video. And this is the part where we compare Pegasus against the Lava Next video model. So all this stuff is just around like boilerplate code to set up Lava Next video. So you sample video, format them in NumPy array, download the model, set up in GPU, format the query in video for the model to consume. I'll quickly skip through this, but this is like kind of the output of, from that processing part. It's just like literally break that video down and generate like NumPy array, which will become like embedding float. Yeah. So yeah, so this is the part where we use LavaNext to ask a question about the video, right? So what is this advertisement selling? And this is the LavaNext response. It said the image appeared to be a creative advertisement for a brand product. So you already see that like this open source model try to look at from an image perspective. They try to convert the video in image frame, right? And they kind of capture like the temporal understanding of the video, and so you can already see the difference between like an open source model versus like our Pegasus model. And then for the rest of the notebook, we did something called multi-video setup. So so in the previous session, we did the charting with the video based on individual segment. What if we want to chart with like multiple segment, right? Like multiple clips, right? So yeah, this is the part where we did that. Did a little bit of work of video upscaling. So we upscale the video into like higher resolution, and then we come up with some current question like who is the actor in the video? What ads is Selena Gomez in, right? And then we did the comparative analysis using both our Pegasus model and the open source model. So this is the section where we use Pegasus to answer a question about the video. Right. So for example, one of the response here is the actor in the Miss video is Natalie Portman. So that's Pegasus answer. And then we did the same for Lava Next video, right? Same processing. And this is the response here. So it said in the video, a young woman is shown wearing a dress and standing by the road. The background feature a large screen view with a huge distance. The woman is actress Charlize Theron, which is not correct. Which is actually Natalie Portman. I can verify that by opening up this one. Yeah, so here's the video. You can obviously this is Natalie Portman. Yeah, so that's a quick walkthrough of the notebook. Perry, do you have anything else to add? I'll just go over.
No, I think that's good, right? And I think you can see how this is applied to lots of different use cases. This is really about, the combination of 12 Labs and Pinecone is really about allowing people to bring their own data into a LLM flow or a video search application, and scoping down your search rather than just Google or YouTube or whatever ChatGPT has, scoping it down to this is the data that I want to search over because I've brought it into the database and I've used the 12 Labs model to extract information from it. So yes, all of this stuff is public. We will share the blog and the notebook and the slides and the recording.
Yep.
Hope this was useful, and I think from the Pinecone perspective, really just trying to make it super easy to do vector search, which is actually quite a complicated thing, and there's lots of technologies out there that force you to jump through a lot of hoops to get there. We try to make it just easy and let the database get out of your way and do all this cool stuff with 12 Labs and video and the other things you want to do.
Yeah, for sure. So I just shared both the tutorials and Colab notebook in the chat. So both of them are public, so you can just play around with it and see this output on the by yourself. By the way, I think Yeah, the notebook. We try to make it pretty interactive as well, so you display, the retrieved clips on the collab itself, right? Yeah. So with the final part of the workshop, I want to quickly go over a couple of slides on ideas that you can build, especially with this hackathon, right? Using 12 Labs and Pinecone. So music and sound, right, which is one of the themes. So an idea can be like a personalized music recommendation system, right? So for example, if you take like video playlists, apply songs, right? You can use our tools to analyze we use Marango to generate audio embeddings, right? From those from the like MP3 file of audio, and then store those audio embeddings in Pinecone. I mean, you can even store the whole video embeddings in video as well. So you can do things like audio to video search, for instance, and based on those embeddings, right, you can do recommendation, right? Like what audio file is most similar to this video input, for instance, right? Visual art. So I think pretty similar idea. So as explained for our Marango models, we can also capture image embedding. So you upload, say, like a PNG or JPEG file of an image, right? Then you can get image embeddings from that, right? Store them into Pinecone, right? And you can do things like image to video search, right? You can upload an image of a picture of a person, right? And then maybe get some video artworks, right, on the internet for those that is like similarly in terms of the themes of style, right? You can create like a collection of your artwork this way. Video and film, this one is big for 12 Labs for sure. This is a big vertical that we focus on heavily. Couple of ideas like interactive storytelling, right? Let's say you go filmmakers, you can upload script and video, and then use 12 Labs to analyze the theme, come up with some ideas, and then use again do the embedding based recommendation suggestions based on those modalities via Pinecone, and video search engine that looks at emotions, right? If you similar to like the semantic search approach, where you like put in emotion as a search query, and then find a matching scene that similar to those emotion. AI gaming is another theme of the hackathon. Upload text, image, or videos, describe your game ideas. Use 12 Labs to extract themes and generate suggestions on Pinecone. Fashion. So like, let's say you have like videos of portfolios of your fashion collection, right? Under like models on a runway, for instance, you can use 12 Labs to analyze some of the key themes of like, what is that dress that model is wearing, etc., right? And then you can curate like a virtual shows, right, with specific designs. And then lastly, multimodal, right? I mean, this is pretty broad, so cross-domain content generator, right? You can let's say create an application that like combine text, audio, image, right? And maybe use them. You can use Mistral or Luma, for instance, other sponsors to generate like net new video, and then from there you can like do all sort of interesting downstream tasks, right? Like you can use 12 Labs for analysis of those net new video, Pinecone for storage retrieval embeddings, of course, and like chat with that new video, for instance, like we did in the workshop today. Yes, that's it for today. Thanks, everyone.
Yeah, thank you. Any other questions? Anybody want to chat about something they're working on?
I really like that 12 Labs Luma for meetings, have all that almost in live real time. Well, I wanted to know about the new Pinecone models. Are they on Hugging Face by any chance?
The Pinecone models?
Yeah, the new well, for me they're new. The new image embeddings and so on.
Yeah, we don't have an image embedding model. We have a text one, and it's based off of the NVIDIA a model that NVIDIA trained that we are hosting. But Pinecone is totally agnostic to whatever model you want to use. So whether it's a model from 12 Labs, a model from Mistral, a model from something running on Hugging Face, anything that produces a vector can then be stored in Pinecone.
Got it.
And I have a question. This is about similarity threshold parameter. When I do a query, a search, then I find that everything is similar to some degree. For example, maybe the similarity is just that I'm in my query, I have a sequence of tokens, and also the records that I have in the database is a sequence of tokens. So my current mechanism is just based on human feedback and cost. But I was wondering that what mechanism do you recommend, something that worked for you, to establish a threshold parameter for this similarity parameter or value?
Yeah, it's hard, and it's very kind of data set dependent, and also end user experience dependent. If you want to give somebody something no matter what, you can give them something at a very low similarity score, and it's still going to be the best that you have. If on the other hand you need to be really tight, and ultimately want to risk not giving them anything because you don't have any record that is close enough, then you can have some cutoff threshold. But it's really very dependent on the data set that you're putting in, how diverse that is, and also how strict you want to be with what you give back to the end user and what you consider a potential hit. And so it's hard for us to say. I've seen in our experience customers generally looking for something over 70%, 75%, as a reasonable kind of level of this is similar, or below that it's really not similar. But again, you could certainly craft a data set that has reasonable similarity all the way down at 50 or 60%, and something could still be interpreted as similar. I think the harder problem is you have lots of things that are similar, and that comes from really tight kind of clustering of data, where too many things actually are a match, and how do you kind of sort and rank within them? I don't know, James, do you have any kind of thoughts on that?
Yeah, I mean, I think it depends on use cases, right? I think I think for the context of hackathon, you can just set something like 70-80%. Typically, is a acceptable threshold. I mean, the higher you set that number, the more precise the retrieval result is going to be. Yeah, but like I think for the hackathon context, probably don't have a lot of data at the first place. So something around yeah. I guess my point you probably do super precise, right? As long as like the search quality is somewhat acceptable, like matching you what you want to search for, then I think that's pretty good, from
Yeah,
perspective.
the other thing I'd say is you can kind of go on this may not be hackathon kind of material, but you can go on a bit of a journey to improve that in a couple different ways. One is, especially if you're working with text, you can add more context to the text, to the chunk that you're creating an embedding from, and that should push the really relevant stuff higher threshold, and give you more separation across the spectrum, and so you can have a higher threshold. And so you take take a chunk of text from a file, from a document, and actually you pass the whole document through the LLM and then ask it to summarize, and you attach the summary to each chunk, and that kind of separates document by document. Or you could take each chunk and pass it through an LLM and ask it to either expand or summarize and attach that as text. And when you embed everything, you get a much deeper, kind of denser representation in the vector. It's harder to do that for images, but you can also kind of what works well for images and text is also looking at metadata filtering. So you can take the information you do know about the image coming in, store that as metadata, and when you do a query, you can use that to filter, say based on time range, or based on data source, or based on end user kind of feature. You can do filtering, and that will help kind of shrink the overall data set that you're searching within, and hopefully push the most relevant results up higher. And the last thing I'd say is you can look at what's called sparse embedding. And this is basically a keyword matching. And that works well for text, but it also works well for images. If you have a lot of labels or tags about the image, you can encode that as a sparse vector, which you can then use in combination, kind of a hybrid search with your dense vector. And so again, just these are strategies to expand the overall quality of retrieval. It takes lots of iterations. It takes lots of application building. You're not going to be able to get something just perfect right out of the box. I think you can get pretty good. You get 75-80% good out of the box.
Yeah. And just one additional point I want to include in that. This might be a bit deeper, but in the industry, there's also this concept called read-rank. And I know like there's a couple of companies in the space also for like a re-rank API. So re-ranking is basically like a step that follow search, right? So for example, like let's say if you call up for the initial search, right, you quickly scan a vast collection of videos to get the process which is related to the job query, right? Then for a lot of our enterprise customers, they want even more fine-grained details retrieval. So maybe they can apply this concept called ranking, conduct a more detailed analysis, then examine each video alongside the query. And such a deeper evaluation will allow like the overall system to understand the context and nuance and precise ranking about the video, right? So yeah, I know there's a couple in the LLM space. I know like I think Cohere have a re-rank API that's pretty one. I don't know if Mistral has one. If you're curious about it, should definitely look it up.
Thank you. These are very valuable. Thank you very much. And I think it's just great for all of us to have this opportunity to learn from the best. I do have one more question. Because you started to talk about a little bit like looking around and then do some experiments. So like I get into a situation that the modality is already defined, so that narrows down the models that embedding models that I can consider. And then some further parts is where the data resides, so that maybe the data should not go out from a jurisdiction over to another one. And then the rest is very much trust-based. But how do you suggest any mechanism to decide between like specialized or generic embedding models or small or large dimensional embeddings? Just already given modality and already given like data sovereign, like data residence. So those are kind of fixed filters. Just there are still so many options afterwards.
Sure. I mean, on the data residency side, Pinecone right now supports U.S. regions and EU regions. We have some APAC regions as well. We'll be continuing to expand that. But the just like any database, the data is yours that you put in there, and it's stored, according to the region that you decide. So you should be able to meet those kind of data sovereignty, data residency requirements. in terms of embedding models, very similar to the generative models. The big ones are really easy to get started with. They cover a wide range of capabilities, and so you probably want to start there. But for the same reasons why you might choose a smaller LLM, you might choose to use a smaller embedding model, right? And those reasons are the ability to fine tune for your particular workload and data set. I don't recommend starting with fine tuning, but it's definitely a way of kind of improving the quality. And it's especially useful for improving quality with less capable models. So smaller, cheaper models that really just from a pure cost perspective, cost and latency, like cost and throughput performance. If you want very high throughput, low latency, and low cost, don't use ChatGPT, right? But there are other models that either open source or even supported hosted ones that, with the right kind of combination of RAG and fine tuning and context management, you can get good performance at a low cost on, or even better performance for domain specific areas. And so the same thing I think applies to the generative LLMs as it does to the embedding models.
Makes sense. Makes sense. And then, sorry, is there perhaps any recommendation from James, from your side? Like, I know you guys have a set of embedding models, but maybe in the future you will have different offers that are competing. Like, how would you decide then in that case?
So right now we only have one embedding. Just go Marengo. We have one video embedding model. And I think like in the future we're just gonna keep making it better, like better performance, better like all the stuff that you mentioned, better latency, better pricing, right? So I don't think we're gonna like try to diversify our output there. Making it works already is already a hard task, so I don't think compete in the language space or like the image space. Right? We just really focus on video space, and what's unique about like that model is I think like it's probably the only video embedding model in the market. I don't know about open source, but at least from what I see, even the big tech or like big AI labs, I don't see any coming out there. So yeah, we just try to make it really like nail down the space and like make a lot of progress from our point of view.
Yeah, and that I think everybody will benefit from it. Because you mentioned that your view is that you will have one embedding model that you are offering, then it kind of triggers a second question, and that is long-term support for a particular model. So once the customer pays for embedding data once, and then you are progressing with the innovation and you have a better embedding model, then what's your view about it? It's like, how will be the transition? And I mean, I think maybe some of us have already experienced it with the other model. I don't know, or with some other models that kind of came and disappeared. And I was just wondering, what's your view about it? That what can the end user do about it?
I think so. We actually have multiple versions of our embedding. So we did like a major model update once a year, and then for example, Marengo right now is 2.0. That's the current version of the model. Last year was 2.6. So if you see on a notebook, even the code when I did with Pinecone was written in 2.6, right? It just like literally a number change. The SDK syntax literally all the same. So the way we support our users and customers, we just automatically migrate the existing video index from 2.6 to 2.7. So they just like automatically get the benefit model without having to reindex the video, right? So that's how we support.
Great.
Yeah, typically, yeah, we always recommend you to try out the new. That's the best performing one.
Yeah. So let's say somebody uses your embedding model in 2025 and stores it in Pinecone stores it somewhere where that user wants, and then 5 years later, that user has 10 times more data set. How do you envision like that user will be able to use your legacy embedding model, or you will somehow encourage the user to migrate to a newer embedding model?
Yeah, generally, like we always encourage people to migrate to embedding model.
Okay, that's good. That's good.
Great. Awesome. So I know, George, do you want to join in? I know I think we had time. Barry just left.
Thanks for doing this. It was really interesting. Actually, I had a question around all this too, if you don't mind. Is anyone using these models on public data? Like, does anybody offer an API to like YouTube or Spotify to look things up?
I actually don't know.
I was just thinking, like, this is all geared towards, on private collections, but it would be cool if you could use the same calls to public sources. But maybe
maybe that's
opportunity.
maybe that's like a cool hackathon project. All right, like if you Spotify, for example, right? Like let's say I think Spotify have an API, so you can like use Spotify API to like just ingest like new podcasts right from Spotify. Leverage our model to like describe the title of the podcast, get like a quick summary of the podcast. So yeah, I mean that's a cool project that you can.
All right. I think we're sort of at the end of our time contract. So thanks everybody for joining. We will put this up on YouTube as well to rewatch. And if you have questions you didn't get to ask, both James and Perry are on the Discord. So you can go to the respective threads that we have in the London Paris Berlin 25 channel. And post the questions there, and they will get answered as best and as soon as possible. All right, thank you guys. Have a successful rest of the day, and good luck with your projects.
Thanks everyone.